Hey everyone, I wanted to demo the League of Legends predictive model and a Discord bot that I've been working on over the last several years. I've been an avid fan of competitive League of Legends since 2012 and work professionally as a data scientist, so this really has always been kind of a perfect confluence of my interests. I wanted to start by definitely giving thanks to Tim Sevenhoysen and the project that he runs over at Oracle's Elixir. Without the support of him, his Discord community, and the data pipeline that he provides to the public, this project never would have gotten off the ground. So please check him out, check out his website, and support him and his work if you haven't already. I'll be sure to include a link down in the description of the video below. The purpose of this video is really just to give a high-level overview of my model, my code, and what the Discord bot is doing. So if there is interest, I would be happy to record some additional videos going forward, explaining more about the statistics that are under the hood, some of the data science applications behind it, the architecture of the code, and even things like coding basics. If anyone's interested in learning how to pick up and modify the code, I'd be happy to build out some more basic tutorials in that sense as well. I'd also like to mention that the entirety of my code is publicly available on GitHub. I'll also be sure to share that link down in the description below. I would absolutely welcome any thoughts or feedback or even any branches or commits that you guys would like to put forward as well. I'm constantly trying to make the code better, make the model better, and really just make the project more useful to the League community overall. And so with that said, I'd really like to get into demoing some of what the bot can do. So you'll notice on the screen behind me that I have a test channel up and running on Discord. This is a place where I've gone ahead and linked up the bot. So if you're interested in actually being able to install the bot on a server that you run or are potentially interested in trying it out, feel free to ping me. I'm on Twitter at @theproject0. You're more than welcome to reach out and chat with me. I love talking about this. I'm happy to answer questions, and I'd be happy to help you guys get the bot spun up in your own channels if you want to give it a spin. So the bot can do a couple things, starting out with some of the basics. It has a few utility functions, so if I type the exclamation point and then do something like schedule, I can actually follow in with the name of the league. Right now, I've only got API pulls for the big four, so I could do something like bang schedule LEC, and with any luck, there we go. I get a quick return of the next 10 games within 5 days. So you'll notice that not only do I get the blue team, the red team, the starting time, which is in UTC time zone, I also get the series type, and then my model as well is able to generate a win percentage and a level of deviation that's coming from the model. I'll explain that one in a bit more depth, but at a high level, really, you just need to understand the blue win percentage goes from 0 to 1 and represents the odds that the blue team is going to win that game. And again, the predictions in my model are built only using data that we know in advance, right? So we're not able to look at things like future draft, and I'll explain in more depth kind of some of the statistics for how this is being computed, but essentially it's really just this command will give you a schedule. Now you'll notice as well some of the notes. The first one in particular is that the predictions are only using the last fielded roster. So for teams that might frequently make substitutions, or if you know that there's an upcoming roster swap, you may have to actually dial this in using an additional command called predict. So a good example of this is recently we had TSM fielding their full intended roster for the first time after using their academy roster for the entire lock-in tournament. So, if you knew that they were going to be using Kiaiduo and Shenyi and the whole team coming into week one, you could actually run bang predict and then be able to actually type in the names of the teams, which, bear with me one moment. Let's just create an artificial map here. So I'm going to use Cloud9, which is composed of, Cloud9 being the team, followed by Summit in the top lane, Blabber in the jungle, Fudge mid, Berserker at AD carry, and then Isles. And actually, if you don't mind, I think that might be Winsome. So let's change that one over. And then if we go for TSM, we'll add them second. So you'll notice that the formula here for Bang Predict is it's Bang Predict to call the command. I give it the team name for the blue team first, followed by top, jungle, mid, AD, and support. And then I give it the red team's team name, followed by, again, top, jungle, mid, AD, and support. There are a few things here that if a name has spaces in it, for example, Hans Sama, you wrap that name in quotes. So we'll just go ahead and fire off Bang Predict as it is now. That'll come through. It'll calculate, and again, right, we'll see that Cloud9 here has a hypothetical 53%, chance of winning the game with a deviation of about 11%. So that's fairly cool. You may be wondering kind of how we get there. We'll touch on that one a little bit more as we go forward, but we can also do things like punch and bang roster to see who that last fielded roster is. So, for example, in the command line above, you'll notice that we called the LEC schedule, and we see Team BDS being the blue side for the first game. If we wanted to know who was on Team BDS, we'll call bang roster, wrap that name in quotes, and then once we fire that off, we'll notice that we get back the last fielded roster of Atom, Syncroft, Nuclear Int, Xmatty, and Limit. And again, you'll note that the model does not track substitutions and roster swaps for upcoming games. That's really on you, the intended user. So we've gone ahead, we've called down a schedule for upcoming games. We're able to pull the roster if we don't know who's playing or who last played on the team. We were also able to call Bang Predict if we wanted to actually punch in for a specific roster or for a substitution. So let's get a little bit under the hood. There's actually an additional command for predicting games that's going to be called Bang Predict _verbose. And when you pop verbose, it's actually going to show exactly which pieces of data are flowing into the model. So for this case, let's use Team Liquid. And we're going to pop in Bang Predict, and it's the same format as Predict. So we have Team Liquid, which we're going to put in quotes, and then we're going to feed it Bwipo, Santorin, Bjergsen, Hans Sama, and Isla. And then we're going to make them go up against... Why don't we put them up against Dignitas? So we're going to create a hypothetical match here where Team Liquid is on the blue side, facing off against Dignitas, and we're going to fire that off. Cool. So, what you should notice at this point, and I can fix the data frame a bit by just resizing my window. There we go. So you'll see that you still get a lot of the same fields that you got with Bang Predict, where we get the blue team and the red team. But now, after deviation, we see the additional components that actually make up the predictions. So you'll notice that we have team elo being a factor. We also have a player-based elo, which is essentially the sum of the individual players that are playing. We're going to have player true skill, and if you aren't familiar with true skill, that is a Microsoft-derived algorithm for ranking players in multiplayer online games. It performs similar to other ranking algorithms like ELO or Glicko, which again I'm happy to go into in greater depth in a future video. But for the sake of this, it's really a ranking algorithm very similar to how ELO works. There's an additional metric here called Team EGPM Dom, which stands for Earned Gold Per Minute Dominance. This is a metric that I built just based off of observations from a couple explorations with linear regression and just kind of reading what others have done in the field. But it looks like earned gold is one of the most predictive statistics for the game in terms of trying to determine who's going to win. So the way that earned gold dominance works is what we're looking at is, say I'm the first place team, right? I'm Team Liquid, I'm stomping everybody. If I beat the 10th place team, right? Say I beat, I don't know if it's going to be a FlyQuest or a Golden Guardians or whoever it may be. But if I beat a struggling 10th place team and I beat them non-convincingly, I get rewarded less than say I beat an Evil Geniuses team who's been doing exceptionally well. They might be the close number 2, and say I stomp them. The earned gold per minute dominance basically rewards based on the ranking of your opponent team and how much gold difference you're able to generate against them. And we're able to feed that in as one of the model values here. And then lastly, what we do is we look at the team's individual recent side win rate. So I use something called an exponential moving average. And through that, we're able to look at, say, the last 9 games. How well did they perform when they're on the blue side? What is their blue side win rate? And then it actually uses a half-life to decay older data to make sure that it counts less over time. So we really are we're taking all the games, but we're valuing the most recent ones more heavily. And so I apologize, that was very a quick and high-level version of this, but essentially that's what you're going to get when you punch this into the model. And the way that my model works is, instead of taking any one of these ranking algorithms or prediction methods, what it does is it creates an ensemble out of all of them. So we actually validate over the last 2 years how much did each way of predicting get right in terms of predicting games. And then we're able to weight each prediction based on how accurate it was over the last 2 years. And so a great example of this, and to show off another command, I have bang validate, which will help you see the validation metrics of an individual model. So we're going to do validation on true skill, and then I have a function that'll give it a graph if you want to actually see how this is performing. So we're going to go true skill, and the graph is equal to true in this case. So I'll fire this off. There we go. And so when you fire this off, what you're able to see is that over the last 2 years worth of games globally, the true skill model performs with roughly a 62.5% accuracy. We get a 0.64 log loss, and then you can see the Briar score of 0.225. These are really good validation metrics that, if you're interested in the statistics behind, again, happy to discuss those in more depth. One of the other things that my model actually generates dynamically is it's able to generate these charts, which are a little bit messy, but the idea is that you're going to have a graph representing all of the games, and on the y-axis we have the red player's true skill, and on the x-axis we have the blue player's true skill. Now, the underlying assumption of this model is that if the blue team's true skill is higher than the red team's, they should be predicted to win. And so there's a hypothetical line here directly in the middle here, and you'll notice that the dots that are on the bottom half of that line are mostly orange, where the blue team's true skill is higher, and then the dots that are on that top and left side here are primarily blue, where the red team's true skill is higher. And so that's essentially what you're hoping to see. Now, you'll notice that there is quite a lot of noise. I don't think any ranking algorithm is truly perfect, and if you can find one that is, I think you're going to make an awful lot of money betting. But being able to kind of validate the individual models like this helps us kind of gut check where we're at, how well we're doing, is there something wrong with the model, and also helps give us a framework to where, if we're going to implement a change, how do we know if the change is making our model better or worse? And so being able to validate the models in real time like this helps us keep a pretty steady head on our shoulders and make sure that we're doing the right things. So there is one other feature that I wanted to showcase, which is another command here called best of. And so you'll notice that when you call bang predict and get the win percentages that I return are specifically intended for an individual match. So if you need to convert that to a best of 3 format or a best of 5 format, you can use another command to take a single match's odds and then convert that into the odds for a best of 3 or best of 5 series. We do this using a multiple probability formula. So essentially, it's the same as trying to say, will a coin, that's 50% odds, land on heads 3 times in a row? There's a pretty simple, straightforward formula for being able to predict something like that. So we can do bang best, I think it's best of. We'll do best of, why don't we do best of 3? And we'll revisit a very fun memory here. Why don't we do, we'll do 100 Thieves. And let's pretend that they had a 60% chance to win against Dignitas. And so you'll notice here that I'm providing bang best underscore of, and then the first argument that I provide is the number of games, which the command will only recognize the values for 3 or 5 right now, as intended, kind of based on what we see in league tournaments. The next argument that you're going to provide is the name of the blue side team. You then provide the odds for the blue side team to win a single game, and then you provide the name of the red side team. So when we fire this off, you'll notice that it's going to return the overall likelihood of 100 Thieves to win that series was 64.8%. And then we actually get the individual game score odds. So the odds of 100 Thieves to win 2-0, 2-1, and then similarly we get the same odds in converse for Dignitas. And I think at a high level, that is essentially what the model is able to do from the Discord side. Just to kind of give a quick update on how that model works, the model's pulling data in from Oracle's Elixir. It is processing it once per day. So again, right, the model doesn't update from game to game or hour to hour. That model updates once a day, and it's roughly at 8 in the morning Eastern time. And then anything after that is going to be pulling the same data. And we do this to be kind of a good consumer of data and not really abuse the data that Tim is providing to the public. So essentially, right, that model's only going to refresh once per day. But that's fine. It's able to kind of pull that in, load that in, and have it up and available for everybody. And that includes the schedule and the games data. Everything else after that, I think, is pretty much straightforward as you see here. Yeah, thanks for watching. I really appreciate the time. If you're interested, please feel free to ping me on Twitter. I'm happy to help get you spun up on Discord or help show off the code. Again, thanks to Tim and the work over at Oracle's Elixir. And yeah, good luck, guys. I look forward to seeing what you guys can do with this.